Hi there. We talked today in class about how to tell whether a function as exhibited in a table is a linear function or an exponential function. And to do that, we're going to be looking at our change in y specifically, because I notice here, for example, in the first table, that my change in x all the way across is +1, 2 to 3 is +1, 3 to 4 is +1. Same with the second table. In both of these cases, my change in x is constant. So I'm going to be looking at my y. In the first table, my change in y, -3 to -2 is +1, -2 to 0 is +2, 0 to 4 is +4, 4 to 12 is +8. And I notice that my y is not growing at a constant rate or shrinking at a constant rate. I'm adding 1, then 2, then 4, then 8. And so it's not going to be a straight line, it's not going to be linear, because if it was linear, a straight line, it would have to have a constant growth, a constant rate of change. And so then my next step is going to be to look at what's the relationship between these differences that I found. What happens to get from +1 to +2, +2 to +4, +4 to +8? And in each of these cases, I notice a pattern of ×2. That ×2 is called a common ratio, and it's our indicator that this function is an exponential function. So again, exponential functions are when you've taken the difference, found either the addition or subtraction that's occurred between my y's, and then look at that addition subtraction piece and see, do I see something being multiplied the same between each, or divided the same between each? In this case, I'm timesing by 2, but it might have been divided by 2. Okay, so with this second table, when I look at -2 to 1, 1 to 4, 4 to 7, 7 to 10, to get from -2 to 1, I added 3. Same with 1 to 4, same with 4 to 7, and same with 7 to 10. And there's my common difference. So common ratio is exponential. Common difference is linear. And there's my answer. Hi there. We talked today in class about finding the average value of a function over a set interval. So this one is number 14 on your 5.3 practice worksheet. On number 14, it gives you an equation y equals 0.5x plus 2, and they actually give you 3 intervals to find the average value over. We're going to do the first one, the one that says 0 to 1. You also have a 1 to 2 and a 2 to 3 that you'll need to do on your own. So for the 0 to 1, we're going to use our average value, our average rate of change function, which is f of b minus f of a all over b minus a. Our b and a are the interval that we've been given, right? So we have our b and our a, so I can rewrite this formula using 1 for my b and 0 for my a. And we talked in class that it actually doesn't matter which one you call your b and your a, just make sure that they still stay lined up. If my 0 is my b, then it should be 0 over 0. If my 1 is my b, it should be 1 over 1. And same with the a. Okay? Well, the f, if you see f of a number, what that's telling you is that this value of x, this 1, I'm going to take that 1 and I'm going to plug it into my equation. I'm going to put it here. So that 1 is going to become 0.5 times 1 plus 2. And so when I plug that 1 in, I get a value of 2.5. And then I'm going to do the same thing for the 0, because when you see f of an x value, it's telling you to take that x value and put it in here. So we're going to take that 0 and put it in for x, and we get 0.5 times 0 plus 2. And I get 2. all over 1 minus 0, which is 1. And 2.5 minus 2 is 0.5 all over 1. And 0.5 divided by 1 is 0.5, and so that's going to be my rate of change, my average rate of change on the interval from 0 to 1. Okay. Number 15 is similar. They've given us an equation of 0.5 times 2 to the x. And again, you have 3 intervals to do for your homework. We're going to do one right now from 0 to 1. So the same equation for average rate of change, f of b minus f of a all over b minus a. Okay, and again, doesn't matter which is your a and which is your b. I generally like making the bigger one my b. This is going to be f of 1 minus f of 0 all over 1 minus 0, since I made my 1b and my 0a. And again, the thing you're going to want to always double check is that these numbers match. These numbers match, right? We don't want f of 1 over 0 or f of 0 over 1. Okay, so the f of 1 is when I take that 1 and I plug it in for x. So I'm going to have 0.5 times 2 to the 1, or to the first. And 0.5 times 10 to the, times 2 to the first is 1. And then same thing here, we're going to take this 0 for x, put it in. We get 0.5 times 2 to the 0, which is 0.5, all divided by 1 minus 0, which is 1. 1 minus 0.5 is 0.5. 1 minus 0.5 is 0.5, still divided by 1, and 0.5 divided by 1 is 0.5. So that is our average rate of change of this equation on the interval 0 to 1. And there's my answer.